Now let us work out the problems in NCERT book one by one. Exercise 1, question number 1 is determine whether each of the following relations are reflexive, symmetric or transitive. So we are considering first question now. Now given set A and relation is defined as x comma y 3x minus y equal to 0. So we need to do 3 check. One is reflexive check, another one is symmetric check and another one is transitive check. So in case of reflexive check, if R, that is the relation, if R is reflexive, then y should be equal to x. Because we know if xy belongs to R, then x should also belong to R for reflexive relation. So we are replacing y with x. Thus 3x minus y can be written as 3x minus x equal to 0, which on solving we get x equal to 0, which is not possible because x equal to 0 does not belong here, because a starts from 1. Thus R is not reflexive. Similarly, going for symmetric check, we know if x comma y belong to R, that is the relation, then y comma x should also satisfy the relation R. Thus 3x minus y can be taken as equation 1, and replacing x with y and y with x, we get 3y minus x equal to 0, which is relation 2. This relation 2 should be valid if relation 1 is valid. From this equation, we get y equal to 3x, and substituting y equal to 3x in this equation, we get x equal to 0. Again, x equal to 0 does not belong to A. Thus R is not symmetric. In case of transitive relation, we know if xy belong to R and yz belong to R, then xz should also belong to R. That is, if equation 1 is true and equation 2 is true, then equation 3 should also be true. Now from second equation, this equation, we get z equal to 3y. Substituting z equal to 3y in equation 3, we get 3x minus 3y equal to 0, which is x equal to y. Now substituting this x equal to y in first equation, we get x equal to 0, which again does not belong to A. Thus R is not symmetric. Thus R is neither reflexive, nor symmetric, nor transitive. The same question can be solved in a different manner as well. Like it is given that 3x minus y equal to 0 is the relation here, and this is set A. Then for x equal to 1, we will get y equal to 3, because from 3x minus y we can get y equal to 3x. Similarly, for x equal to 2, we get y equal to 6. X equal to 3, we get y equal to 9. X equal to 4, we get y equal to 12. For x equal to 5, y will be equal to 15, but here in set A it is restricted up to 14. Hence the required subsets are 1, 3, 2, 6, 3, 9 and 4, 12. So when we go for reflexive check, both the elements in the subset should be same. Of course, we do not find any 1 comma 1 or 2 comma 2 or 3 comma 3 for that matter. So reflexive relation is not possible. Symmetric check, if 1 comma 3 is there, then 3 comma 1 should also be present here. But there is no 3 comma 1 here, and hence symmetry relation is also not possible. Transitive relation, we have 1 comma 3 here, we have 3 comma 9 here. Whether we have 1 comma 9, we don't have, then it cannot be transitive as well. So this is also a method with which we can determine whether the given relation is reflexive or symmetric or transitive. But still, we prefer or we suggest that you follow the first method, because there will be situations where you may not be able to form the subsets. For example, if set A is defined as set of all real numbers and a relation is given, then you cannot keep writing the subsets because it will be too huge. So have a good grasp of both these methods, and wherever possible use the first method.